Lesson 1.6 is on multiplying and dividing real numbers. It starts on page 38, but we're actually going to skip over and start on page 39. Top of page 39 talks about multiplying real numbers. Multiplying where we potentially have negative numbers we talked about before. Remember, this is like the good guy, bad guy thing we talked about last year. So if you multiply and you have different signs, your answer is going to be negative. They're modeling this on the number line. So 2 times -3, it's like you have -3 and you have another -3, you've got -6. So like if you borrow $3 twice, you're going to owe $6. Or if you think of the good guy, bad guy, this would be like the good guy leaves town is bad, if you remember that chart. The next one, 2 times 3 is 6. Obviously, we know that. And I guess going back to that top part, besides 2 times -3, we could also look at -2 times 3. Also would be -6. That would be like a -2, a -2, a -2. That gives us -6. Okay? Or you could say that's the bad guy comes to town is bad. If the signs are the same, it's positive. 2 times 3 we know is 6. The only one that's a little bit tricky maybe to think about, negative times negative is a positive. The best example I could give would be maybe somebody paying you back money that they owed you or something like that. But negative times negative is positive. That's like the bad guy leaves town, and that's good. So if we look at problem 1, they're doing some multiplication there. Mostly it's just looking at our signs. You can see the first one is negative, second one is positive, third one is negative. The last one, since it's in parentheses, -3 squared, that means -3 times -3, which would be a +9. If it wouldn't be in parentheses, if it would be written like this without the parentheses, basically that's saying opposite of 3 squared if there's no parentheses. And so actually that negative sign would just come over, and then 3 times 3 is 9. So that would be -9 if there were no parentheses. Since there are parentheses, we know what's in the parentheses is being squared, so it's -3 times -3, which would be a +9. As we go through these, we are going to be, unless the numbers are really crazy and we're doing a ton of problems, we're going to be doing these without calculators as well. So if we look at the got it, they want us to find these products. So for part A, 6 times -15, we can multiply, act like the negative's not there for a minute. And we get 90, but then we've got a positive times a negative is negative. So -90 would be our answer for that one. Part B, we're just multiplying 2 positive numbers together, so that's going to be a positive. Remember, when you multiply decimals, your decimals don't have to be lined up, because we're going to decide afterwards how many spots the decimal needs to get moved over. So move it 1 spot to the left would be 2 4/10. If we go over to part C, I'm not a big fan of where they put their negative sign there. I like it up with the numerator where we can see it. Multiplying fractions, we don't have to have a common denominator. We can just multiply straight across. So if we multiply these, -7 times 3 would be -21. 10 times 5 is 50. And we can't reduce that, so -21/50 would be our answer. And part D, going back to what we talked about earlier, -4 is in parentheses, so that means we're doing -4 times -4. Negative times negative is going to be a positive, so that would be a +16. And one more time, like we mentioned earlier, if there were no parentheses, this would be a different problem, but if there were no parentheses, we're going to do the exponents first here. This negative sign's just going to drop down, and the 4 squared is what we're doing here. So 4 squared, 4 times 4 is 16, and so that answer would be a negative 16. Look at the next part. We're going to simplify square root expressions. So problem 2, part A. Basically the negative, we can just bring the negative down, and then the square root of 25 is 5. So 5 times 5 is 25. Part B, this we haven't seen too much of yet. This is plus or minus. It just means it could be a positive or a negative. It means we have 2 different answers. Like we talked about before, you can split this up. So on a problem like that with the square root with a fraction, you can split it up as the square root of the numerator, square root of the denominator, and then square root of 4 is 2, square root of 49 is 7. So that would be plus or minus 2/7, which means either 2/7 or negative 2/7. There's 2 possible answers. So let's look at the got it 2. So part A is the square root of 64. We know 8 times 8 is 64. So a question you might have, you might think, well, what about negative 8 times negative 8 is also 64? And that's true. What we're going to do is, if the square root symbol is already there, then we are going to do what's called the principal square root. So the principal square root, it's kind of like just the main thing we normally deal with. And so if the square root symbol is already there, we're just going to take the positive answer. Okay, now different than that, and we'll get into this stuff later, so don't worry about it too much. But if you were doing like a problem and it said x squared equals 4, if you were solving that problem, right now there's no square root symbol. In order to solve this, the x is being squared. We would take the square root. When we add the square root symbol, we would also need to add a plus or minus in front of it. So this would be plus or minus 2, which means that x could either be 2 or it could be negative 2. Okay, this problem, when we're solving for a variable, has 2 answers, because x could have been 2, which would be 2 times 2 is 4, or it could be negative 2. Negative 2 times negative 2 also is a positive 4. So when we add the square root, we add plus or minus. If the square root's already there, that is the principal square root. We're just going to take the positive answer. Part B, the square root's already there, but we do have this plus or minus already in front. So square root of 16 is 4, but then that plus or minus comes down. So plus or minus 4, which means 4 or negative 4. So in part C, we've got negative square root of 121. So this negative sign we can bring down, and then square root symbol's already there, so we're not going to add any signs or think about multiple answers that would work here. 11 times 11 is 121, and so that would make negative 11 our answer for part C. And then part D, you can split that up if you want. And so that would be plus or minus 1/6, which means either 1/6 or negative 1/6. So on page 40, if we look at the key concept, talks about dividing. Dividing, it's the same idea as multiplying as far as the signs go. If we have different signs and we divide, then it's negative. So like negative 20 divided by 5 is negative 4. 20 divided by negative 5 is negative 4. If we have the same sign and we're dividing, it's going to be positive. So 20 divided by 5 is 4. Negative 20 divided by negative 5 is 4. So if you look at, and if you have a division with 0, if you have a number divided, if you have 0 divided by a number, that's equal to 0. So like 0 divided by 8 is 0, okay? So if I have $0 and I say I'm going to split my $0 between all 8 of you so generously, you all get nothing, right? On the other hand, if we have 8 divided by 0, if I have $8 and I try to divide that between 0 people, that doesn't make sense. You can't divide by 0. So dividing by 0 is undefined, which you might remember from last year when we did slope and the slope dude video where he was skiing. Undefined. Okay. So if you look at problem 3, a skydiver's elevation changes by negative 3,600 feet in 4 minutes after the parachute opens. What's the average change in elevation each minute? Okay, so we're just going to divide out the feet by the minutes. If you divide that out, negative divided by positive is negative, and 3,600 divided by 4 is 900. So negative 900 feet for that one. Got it? 3. You make 5 withdrawals of equal amounts from your bank account. The total amount you withdraw is $360. What is the change in your account balance each time you make a withdrawal? So withdrawal is taking money out of your account. So altogether withdrawing 360 would be like negative $360. And we have 5 withdrawals. So if it was the same amount each time, we would want to divide that up by 5. And so this would probably be something we would be working off to the side just to make sure we're doing this right. So 5 goes into 36 7 times is 35. 5 goes into 10 2 times. And so this would be equal to negative $72. So withdrawing $72 every time. Inverse property of multiplication describes relationship between a number and its multiplicative inverse. Another word or phrase, another word instead of this phrase we could use would be reciprocal. So instead of multiplicative inverse, we could say reciprocal, and that's going to be what I'm going to call it. But these can be used interchangeably. So the idea with this reciprocal or multiplicative inverse is we multiply them together and we get 1. So reciprocals or multiplicative inverses are 2 numbers whose product is 1. We multiply them together and we get 1. So for example, 2/3, the reciprocal of that would be 3/2. If we multiply 2/3 times 3/2, that would be 6/6, which equals 1. One thing you'll notice as we do these is if you do the reciprocal, you're just switching the numerator and denominator, flipping the fraction, some people say, okay? But we want to use the mathematical term reciprocals. If we have 5, think about the reciprocal of that. So the 5 we could write as 5/1, and so then the reciprocal of that would be 1/5. We could also have reciprocal if we have a mixed number. So let's say we've got -1 3/4. One thing with a mixed number like this, a negative mixed number, if you're going to change that to an improper fraction, probably best just to ignore the negative for a minute and then just know your answer is going to be negative. So -1 3/4 is the opposite of 1 3/4. So whatever 1 3/4 is as an improper fraction, -1 3/4 is going to be the same, just with a negative sign by it. So if we just ignore the negative for a minute and just look at this part, 1 times 4 is 4, plus the 3 on top is 7. So that would be -7/4. So then the reciprocal If you flip that, then you could say it's 4 over negative 7. As long as you put the negative one spot or the other, it's okay. Typically, they'll put the negative in the numerator, or like the book does, next to their fraction bar. But if you have it in the denominator, that's fine. If you have 4 over negative 7, that's fine. And like I said, just to test the theory here, just to show you, this would be negative times negative, that's a positive. So that's equivalent to 1, so those are reciprocals. So it talks a little bit more about this on the next page with reciprocals. And then they're showing why it works. With them showing why it works, they've got all these letters. I think for a lot of people, myself included, when they're just using variables, it's harder to relate to. So I'm going to show you the same example basically, only with numbers, and see if this makes more sense than what they're doing. So this is dividing with fractions. So dividing with fractions, we've talked about it before, keep, change, reciprocal, just to show you that it does work and it's not just some magic trick that we're making up. Dividing, we could put a fraction bar. So 1/2 divided by 3/4, we could write it like that. And then this is like a complex fraction because we have a fraction and a fraction. So this is not considered simplified still. We can't just leave it like that. So what you could do in the denominator, we could multiply by the reciprocal to get a 1 down there. That's going to make it to where we don't need that part of the fraction anymore. As long as we do the same thing to the numerator and the denominator, then we're okay. So this would be, in the numerator, you could say it's 4/6. In the denominator, it's 12/12, which is the same as 1. And then 4/6 you could reduce to 2/3. So 2/3 divided by 1, which is 2/3. Okay. Now, like I said, we're not going to do the problems like that. You can just do like you've always done, keep, change, reciprocal, and then reduce. Or you could have reduced the 2 and the 4 before you multiplied if you want. Okay? So if that other thing I showed you was confusing, you don't have to worry about it, but I just am showing you that this works for dividing fractions, keep, change, reciprocal. Also, if we have improper fractions, you need to change those to mixed numbers and then keep, change, reciprocal. If you look at problem 4, is basically the same idea, only with variables. So they rewrote the problem, they wrote it sideways, and then keep, change, reciprocal, and then they worked that out. So if you look at the got it, we can do keep, change, reciprocal. If you want to reduce, you can. Just watch when you reduce that you don't lose your negative sign. So that would be -3/10. Or you can, if you didn't reduce, you get -6/20, and then you can reduce that down. 2 problems we're going to try to do that are not in your book. Or actually, maybe just one. Never mind, just one. 2 1/3 divided by -1 5/8. Just to practice one with mixed numbers. So 2 1/3 would go to 7/3. -1 5/8. Ignore the negative for a minute, or rewrite it underneath and then ignore it, whatever. That would be -13/8. And then we're going to keep, change, reciprocal. And like I said, if you want to just keep the numbers exactly in their spots, that's fine. And then we can adjust later if we want to move our negative to the numerator. So this would be 56 over -39. Or you can switch the negative if you want. And and you can actually technically leave it like that. Since it's not a word problem, we don't really know what's happening here. Otherwise, if you divide it out as a mixed number, would be -1 and 17/39. So this gives you an idea about multiplying and dividing real numbers. Have a good day.